This is the Math 2 lesson summary video for the lesson entitled Special Rice. The purpose of this lesson is to develop the relationship between the lengths of the sides of a 45-45-90 triangle and a 30-60-90. In the diagrams below, this summarizes the relationship in a 45-degree, 45-degree, 90-degree triangle. The two legs are the same length. Opposite the right angle will be root 2 times x. In a 30-degree, 60-degree, 90-degree angle, the side opposite the 30 degrees will be x, side opposite 60, x root 3, and opposite 90, 2x. We will practice this throughout this lesson. In this lesson, we use our knowledge of the Pythagorean theorem as well as what we have learned so far in this unit on right triangle trigonometry. In number 1, we are asked what we would need to know about a right triangle in order to use the Pythagorean theorem. So if I do have a right triangle, like so, and I know that my angle here is 90 degrees, we are asked if we need to know, or if we know two side lengths, like this is 3 and this is 4, how we could actually find the third side length. And we actually know from prior knowledge that we can use that Pythagorean theorem in order to find the hypotenuse. And when we solve this is what we call a Pythagorean triple, we would get 5 units long. We are then asked what we would need to know about a right triangle to use right triangle trigonometry. Recall that we would need one acute angle measure and one side length in order to use our sine, cosine, and tangent functions. So what that means from our prior knowledge is that if we are given a right triangle and we have an angle, we would also need to be given a side length in order to find another side in that right triangle. We are told that it is possible in some right triangles to only know an angle and a side and be able to determine the values of the other sides without using trigonometry. These are known as special right triangles, and that is the main goal of today's lesson. We have two special right triangles that we are going to learn in this lesson. The first triangle that we're going to look at is what we call a 45-degree, 45-degree, 90-degree right triangle. We are asked to draw a 45-degree, 45-degree, 90-degree triangle and assign a specific value to one of the sides. So what I've done below here is I've drawn my 45-degree, 90-degree triangle, and I've labeled one side length 5 centimeters. So we're asked to fill in anything else we would know about this triangle. If one leg is 5 centimeters, then the other leg must also be 5 centimeters, because we know this is an isosceles triangle, where two of the interior angles are congruent. By the Pythagorean theorem, we could find the length of the hypotenuse by performing 5 squared plus 5 squared equals x squared. 5 squared is 25, plus 25 is x squared. 50 equals x squared, and we would take the square root of both sides. Recall, to simplify a radical, we would break it down into a perfect square, square root of 25 times the square root of 2, and the square root of 25 is 5. So we can say that the length of the hypotenuse in this right triangle would be 5 root 2. Coincidence that this number in front is the same as the length of the leg? Well, we're going to have to see. So let's try that again in another example. Again, here's a 45-degree, 45-degree, 90-degree triangle. If one side length is 9 centimeters, we know this is isosceles, so this side must also be 9 centimeters. To find the length of the hypotenuse, we can use our knowledge. 9 squared plus 9 squared equals x squared. So we have 81 plus 81 equals x squared. Therefore, we have 162 equals x squared. Take the square root of both sides. Again, recall, we need to find a perfect square, which we know is 81, times the square root of 2 equals our x, and that would give us 9 root 2 equals x. So if you notice here, there is a pattern. Each of the legs in a 45-45-90 triangle, the two legs will always be
the same length because it's isosceles. The hypotenuse will always be the leg times the square root of 2. So let's summarize this finding. In a 45 degree, 90-degree triangle, the legs have a length of x, and the hypotenuse, or the side opposite the 90 degrees, is always x root 2. This relationship is important. You can use this relationship to figure out any side lengths in a 45 degree, 90-degree triangle without having to use the Pythagorean theorem. We then went on to another special right triangle, a 30 degree, 60 degree, 90-degree triangle. So in number 5, we are asked to draw a 30, 60, 90-degree triangle and assign a specific value to one of its sides. What I'd like to do is show you first an equilateral triangle with an altitude drawn. Recall that an altitude is also known as the height if it is an isosceles triangle. So what I've highlighted there is the altitude. Now if this is an equilateral triangle, so let me write that down. If the large triangle is an equilateral triangle, we know that all three sides will be congruent. Therefore, AC is 2x, CB is 2x, and the whole length of AB will also be 2x. Likewise, if this is equilateral, we know then that all the angles will be 60 degrees. This big angle will be 60 degrees, and this angle B will be 60 degrees. So let's fill in any missing information that we know. If AB is a length, or has a length, the line segment AB has a length of 2x, I know then the length of AD and the length of BD should be x, because the altitude is going to bisect or split the base into two equal parts. So I know I can label ADX and BDX. Now, if angle 1 plus angle 2 is 60, I can then say angle 1 will be 30 degrees and angle 2 will be 30 degrees because the altitude will also bisect this angle. So I'm going to label that as 30 degrees, 30 degrees. Okay, so now what I'm going to do is I'm going to take this rightmost triangle, I'm going to highlight it for you here, and I'm going to redraw it below. So right angles at D, C, and B, H, this is 30 degrees, this is 60 degrees, we know this is X, and we know this is 2X. So using the information that we used in the first part with the 45, 90-degree triangle, we're going to plug into Pythagorean theorem using our side lengths. So in this right triangle, we could say that h squared plus x squared should equal the quantity 2x squared. Notice I put parentheses around 2x because it's the whole length squared. So when I'm trying to simplify, I have to square 2x. Squaring 2x means you're writing 2x out twice. So that would be 2 times 2, or 4. X times x is x squared. This would simplify to 4x squared. Bring down our h squared plus our x squared. So let's try to get h by itself so we can solve to figure out the relationship between each of the sides in a 30, 60, 90 triangle. I'm going to subtract x squared. I get h squared equals 3x squared. To get rid of a square, I'm going to square root both sides. I'll get h equals the square root of 3 times the square root of x squared. And we know that those will cancel, so it will end up being x times root 3. So now we have all three sides in this triangle in terms of x. So these relationships are important. These are the relationships in a 30, 60, 90 triangle. So let's generalize this underneath number 6 on the previous page. In a 30 degree, 60 degree, 90 degree triangle, so let's go back and look at our diagram. Opposite the 30 degrees is always x. the length of the shortest leg. Opposite the 60 degrees is always a length of x root 3. And opposite the 90 degrees is always a length of 2 times x, or 2 times the shortest leg in the right triangle. So our relationship opposite 30 degrees is x, opposite the 60 degrees is x, the leg times root 3, opposite the right angle, or the 90-degree angle, is 2x. This is the relationship in a 30, 60, 90-degree triangle. So let's now apply this to some examples. In part A, you notice that there are 2 tick marks. And in geometry, that means that those side lengths are congruent. So we automatically know that x is 9 centimeters. If these are congruent and one angle is 90, we do know that these are 45. So recall that in a 45, 45, 90-degree triangle, the relationships are x, x, x root 2. Therefore, y in this diagram, which is opposite the 90-degree angle, will be the leg, which is 9 times root 2. And we're done. In B, we also notice that there are tick marks. So we know that this is an isosceles right triangle. If one leg is 5 centimeters, then x must also be 5 centimeters long. Opposite the 90-degree angle, we know should be x root 2. Therefore, the side length, or the y value, is 5 root 2. In the last example, we can see one angle is 30 degrees, one is 90 degrees. Therefore, I'm missing angle 60. This is our 30, 60, 90-degree relationship. Recall opposite the 30 degrees is x, opposite the 60 degrees is x root 3, and opposite the 90 degrees is 2x. If it helps, I would label all of your sides. So opposite 30 is x. It's already labeled x. Opposite 60 is x root 3. Opposite 90 is 2x. Now, in order to find x, we're only given the hypotenuse. So what we'll have to do in this case is set 10 equal to 2x to find x, or the shortest side length. So 10 equals 2x. Therefore, x is 5. Once we get x, we know that this side is 5. We know the side opposite 60 degrees will be 5 root 3, and we already know the hypotenuse. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.